Hello and welcome to the third video. In the first one we looked at reflection, the second one we looked at refraction and total internal reflection. In this one we're going to look at lenses. Now in particular we're going to be looking at something called the diverging lens, as you can see from your first syllabus point. We're also going to come across some new terms, principal focus and focal length, and the principal axes as well. And then in these ones we're all going to be drawing ray diagrams to see when we place the object at different locations, where does the image appear? And that's quite important. So let's start off with the converging lens. You don't need to know about the diverging lens. This is a converging lens. It's thicker in the middle. Now what we always draw, just like when we used to draw the normals, but with lenses we always draw something called the principal axes. And this goes through This goes through the middle of the lens and kind of right angles to a line through the center like this. Now there's always this point where the light focuses, which we call the principal focus. Now to explain that a bit better, let's draw some rays coming in. What we always do is we draw rays coming in parallel to the lens like this. Now what those rays will do, if they're coming in parallel to the principal axes, they will focus or pass through the principal focus like this. So that's the way to find it, is you send in rays parallel to the principal axes and they will focus at what we call the focal point, or as you can see in your syllabus they call it the principal focus. Now there's some good news. Well, if we send the rays in going from the left side in like this, well they'll focus at some point over here, and it's nice and easy to find that because it's the same distance as it is on this side. So say this was 3 centimeters, then this would also be 3 centimeters. And we call that distance the focal length. And that is the distance between the lens to the principal focus. So these are all the key terms that we need, and now we can look at the other syllabus points and see how we can use these ideas, draw ray diagrams to find out where the image will appear. In this image here we have a lens, we have the principal axes drawn on, and we have the focal points marked on, where F is the principal focus and 2F is just 2 times that, so twice the distance. So if one was 1 centimeter, the other one would be 2 centimeters. Now we're going to consider the case where the object is at a distance greater than 2F. What does that mean? Well, that means the object's somewhere over here. And we often represent an object with just a nice exciting upwards arrow. Or physicists, we don't like to get too excited over these things, but it is cool. So let's now draw a ray coming from the top of our object. So from the top of the arrow. I'm going to do my rays in red. As this ray comes along, parallel to the principal axes, as we said earlier, if it comes along parallel to the principal axes, it will focus or pass through the focal point. So it'll pass through there like that. Now also there's another special ray we can draw, because there is an infinite number of rays. They could go up through there, they could go through there, they could go through there, but there's 3 that you always draw because they're easy to draw. Now the other one, which is easy, is if it goes through the center of the lens, it will continue on straight like that. So if it goes through the center, we can just continue it on like that. Now we've got enough rays to find where the image is going to appear, because where those rays intersect, you might remember that from video 1, that's where the image will appear. Now, how can we check this? So sometimes in the exam they'll ask you to draw a third ray to check that, or it's always just good practice to draw this, to be honest. Well, if you think about it, if we go in reverse, or if we go through this focal point on the left-hand side of the lens, like that, well, where do you think it's going to go? Well, do it in reverse. Remember, if this one went almost at this ray in reverse, going that way, see it's going through the focal point, and then it goes parallel to the principal axis. So this one is now going to go parallel to the principal axis, and wow, look at that. I love it when it all adds up. It meets at that point. It's kind of a check and confirms that's where the image will be. Now, what do we know about this image? Well, if you compare it in size, see it's going to be diminished. That word basically means smaller. It's also going to be inverted. That basically means upside down. You can see it's below the principal axis, whereas the object over here was above and pointing upwards. This one's below and pointing downwards. And because the light rays actually pass through that point, they don't appear to come from there. This is a real, not virtual image. You could project it on a screen. And in fact, this is exactly what happens in your camera or your phone camera or camera that you have at home. The object, it might be you in front of the Eiffel Tower, appears upside down, smaller, so it can fit onto the camera film. And it's a real image, otherwise you wouldn't actually be able to process it. You need the light to actually land on the receptors. Now remember, this is only when the object is beyond 2f, so beyond 2 times the focal length. In this part, we're now going to consider the case when the object is between f and 2f, not on f and not on 2f, but somewhere in between. So that could be there. Now bear in mind, if it was bang on f or bang on 2f, that gets complicated. That's not what you're going to get in this sort of scenario. So it's between f and 2f. Now we're going to follow the same rules. This is why I love this. You're just following some rules and drawing some nice lines. So remember, you start off by drawing a ray that goes from the top of the object to the lens. You can go to the center of the lens and bend it, but actually in real life, just a little note, it would have been there when it enters or refracts there, and also refract when it leaves, but it's easier when you're doing ray diagrams just to bend it once. And remember that that ray will pass through the focal point. Now think back, what was the other ray we're going to do? Well, remember you can do one that goes through the middle, like this. There we go. And remember, 2 is enough to find out where the image is. So we know the image will be somewhere over here. But being good physicists, we like to check. So we do a third ray. Remember, this one goes through the focal point on this side, somewhere about there. And it should, if you've done this accurately enough, oh yes, look at that again. A bit lower, but that will do. Go through where the others meet. So we can find our image. In this case, the image is here. And we can see that it is real again, because the rays actually meet there. It's inverted again. So it's pretty much the same as the last time, but there's one big difference. And this case is that it's enlarged. So in the other case, it was diminished, but in this case, it's actually enlarged, so it's bigger. And now we're going to talk about my favourite example, which is a magnifying glass, and that's when the object is between f and the lens. That means somewhere in this region over here. Now you might be wondering, how do we know where f and 2f are in the exam? Well, they'll give you at least one. They might tell you this f is 2 centimeters from the lens. Well, remember, to find 2f, you just need to double that, so you know that would be 4 centimeters. And remember, it's symmetrical on the other side, so it would be 2 centimeters that way and 4 all the way to the other end. So let's now put our object somewhere between the lens and f. And this is how a magnifying glass works. You might have noticed that the lens looks a bit like this. It's thicker in the middle. Now the only way to know what's going to happen, well, is to draw our rays. Remember, we start from the top of the object, goes into the lens, and that bends to go through the focal point. The other one, if you remember, goes through the center of the lens, and that continues on straight like that. Now you can see the problem here. Unlike last time, these don't meet. So if we were looking from this point here, there's our physics eye. We're looking from here. The rays are coming into here. Well, what do we see? Well, I used to like traveling in straight lines, so we imagine it travels in a straight line back. And what we see is the following. I put my ruler on this line first of all. What I'm going to do is I'm going to continue this ray back. I'm doing it in a dotted line because this is not actually where the light's travelling, but it's where we interpret it to be coming from. If I put this one here, you'll do it a bit better than that in the exam. Continue it back, and look, the great news is they do actually meet about here. So this is where our image is going to appear. Just going to write over here. This is our image. This was our object. So you might be looking at an ant or something with the magnifying glass. And as you notice, the image is enlarged. Well, it's bigger than the object was. It is upright this time, unlike the other ones which were below the principal axis, that line there. This is upright. And in this case, it is virtual. Why? Well, we've had to dot the lines back to see where the light comes from. So the light doesn't actually come from that point, and we wouldn't be able to project this onto a screen. It's only because we interpret the light to come from there. Now, you wouldn't see this if we were looking from this side. Well, you wouldn't see it. You've got to be looking from the other side to where the object is, so the light can go into your eye. This is how a magnifying glass works. And if you've got one at home, you can have a look for it. It only works when you're close to the object, and that's because you need to have it between the focal point and the lens. If you hold it far enough away, hold it at arm's length and look for it, it's really cool. You'll actually see the room upside down, as we described earlier, and that's because it's beyond 2F. So it's upside down. And if it's between F and 2F, you might get the other one as well, where it was enlarged. What do you need to know? We need to know all three ray diagrams, how to draw them. You also need to know what sort of image is created. So just learn that or know how to draw the ray diagram so you can deduce it. So in the case, you need to know whether it's enlarged or diminished or the same size, whether it's upright or inverted, and whether it's virtual or real. The only one that is virtual is the magnifying glass, and that's when the object is in this region here. And remember, for the magnifying glass to work, you need to be looking from this side where the eye is over here, so the rays of light can come into your eye. If you're looking from this side, well, you'll just see the object and the lens behind it. You wouldn't actually see an image. You'd only work if the object was put over this side here. Please go back and pause the video at any points if you want to try drawing them yourself, or have a go at, perhaps do it on paper, have a go at drawing it, and then you can continue the video to see if you got it correct. If we go back now, there's our three beautiful images, to our syllabus points. You can see that we've now covered all of these. What does the nature of the image mean? Well, that's what I talked about earlier, whether it's real, virtual, upright, inverted, and so on. In fact, there we are, tells you over here. The magnifying glass was the last example when it was between F and the lens. And we talked about real and virtual images. Remember, the way to know real is where the light rays actually pass through, whereas virtual, you have to dot the rays back, and it's where they meet. This is only the case for mirrors and the magnifying glass up here. Any other cases, you get a real image. Well, in GCSE so far. And the ray diagrams is what we drew earlier and what we talked about. Remember, the italics will only be on the extension paper. And to see the real image, we talked about the two scenarios there. We've also talked about what a converging lens is and what it does to a beam of light. Well, it converges the beam and focuses the parallel rays at a focal point, or principal focus, and that's this definition here. And the focal length is that length there between the lens and the focal point. A nice easy topic. Hope that video made sense. We all love lenses.